The universe is an ocean, vast and unending, its waves made not of water but of light, gravity, and time. In this endless sea, most of what drifts across its currents never touches us. Entire worlds, shattered moons, and ancient fragments wander in silence, passing unseen between the gulfs of stars. Yet, every so rarely, one piece of cosmic driftwood washes upon the shores of our solar system, a messenger from realms unknown. In 2017, that first fragment appeared. It was named ʻOumuamua, a scout from afar, shaped unlike any comet or asteroid ever seen. It carried with it the unsettling knowledge that our solar system is not isolated, but open to the debris of other suns. Then, in 2019, came the second, Borisov, a cometary ghost from the icy edges of another system, glowing with alien frost. Humanity realized it was no longer alone in its silence. The stars were speaking through objects, and now a third has come. Astronomers call it 3IATLAS, another wanderer, another riddle, a fragment of something that lived and died far beyond the reach of our telescopes, now gliding past our sun as if by chance. It is faint, fragile, and fleeting, yet profound in its arrival. What stories do such objects carry? Are they shattered remains of distant planets, orphaned children of violent star systems, or quiet emissaries bearing truths of the cosmos we have yet to decipher? Each one forces humanity to confront the same unsettling thought. The universe is not a closed book, but an open sea, and its tides are carrying messages to our doorstep. 3IATLAS is one such message, a stranger between the stars. The story of 3IATLAS begins, as so many stories of the cosmos do, not in the silence of space, but in the patient glow of human machines turned skyward. On the slopes of Haleakelbe in Maui, where volcanic rock meets the restless Pacific, the Pan-STARRS observatory peers each night into the abyss. Nearby, the Asteroid Terrestrial Impact Last Alert System, ATLAS, scans for faint moving lights, its duty to guard Earth from wandering rocks that could one day fall upon it. These eyes of glass and silicon are modern lighthouses, sweeping their beams across the heavens in search of shadows that do not belong. On the night of April 23, 2019, Atlas did what it was built to do. It caught a faint trace of motion, a fragile point of light drifting against the background of fixed stars. At first, it seemed like many of the thousands of small comets discovered by such surveys each year, ordinary, anonymous, destined to pass the sun and vanish into obscurity. The data flowed in as expected: coordinates, magnitude, trajectory. Yet, even in those early hours, there was something different, something uneasy about its path. When astronomers plotted its motion across the celestial grid, the numbers resisted conformity. Its orbit did not close upon itself like a comet bound to the sun. It did not belong to the solar system's architecture of ellipses. Instead, its arc bent too wide, its speed too high. Even with limited data, the conclusion whispered through equations was startling. This was no native of our system. Its path was hyperbolic, the mathematical signature of an interstellar traveler. For a moment, there was disbelief. Computers churn out anomalies every night, false signals that vanish under scrutiny. But the more carefully the data was cross-checked, the clearer the truth became. This faint visitor was on a one-way voyage, arriving from beyond the sun's dominion, destined to pass and never return. Humanity was glimpsing only the third confirmed interstellar object in its history. The designation followed quickly. 3I Atlas, 3I, 4 third interstellar, following ʻOumuamua and Borisov. An atlas for the system that first caught its glow. In the language of science, its name is simple, functional. Yet, within those few characters lies a story of cosmic exile, of a fragment cast adrift from a star not our own, wandering for eons until by chance it brushed the sun's light. The atmosphere in the astronomical community shifted almost overnight. Memories of 2017's shock still lingered. The sudden appearance of ʻOumuamua, the first true messenger between the stars. Its elongated shape, its strange acceleration, its silence where cometary tales should roar. ʻOumuamua had unsettled every assumption. Then, in 2019, came Borisov II. Unlike ʻOumuamua, it looked almost ordinary. A comet venting gas, shedding dust, glowing with the frozen ices of a different star system. Two visitors in such quick succession had seemed almost miraculous. To imagine a third, arriving scarcely a year after Borisov strained belief. For centuries, humans had looked up without ever confirming a single interstellar wanderer. Now, in less than 3 years, the universe had delivered 3. It was as though a locked door had suddenly been flung open, and the void was spilling its secrets faster than anyone had dared to imagine. Astronomers across the globe turned their telescopes toward the faint streak now known as Atlas. It was fragile in brightness, never shining like the comets that dazzle the human eye. Only through long exposures, hours of staring, could its image be coaxed out from the noise of the sky. Yet even in its weakness, it carried weight. Every photon captured was a message from beyond the sun, encoded across light years, whispering of alien origins. Data flowed through networks, observatories in Hawaii, Chile, Spain, and Arizona, all tracking, all contributing measurements. The minor planet center, the nerve center of orbital calculations, gathered reports, refining the trajectory hour by hour. The more precise the orbit became, the less doubt remained. Its eccentricity, the measure of its curve, was greater than 1. That simple number confirmed its exile. Only a body arriving from outside could carry such speed, such geometry. And yet, speed is a double-edged truth. To move fast enough to escape the sun forever is also to move too fast for deep study. Astronomers knew their time was short. Within weeks, the object would fade beyond the reach of most telescopes. The window to learn, to gather every possible detail, was mercilessly narrow. Scientists stayed awake at odd hours, scheduling emergency observing runs, fighting weather, battling for minutes of precious telescope time. There was urgency, but also awe. For many of those who watched the faint smudge of ATLAs crawl across their detectors, there was the quiet recognition that they were witnessing something unique. Each interstellar object is more than a rock. It is a witness. It carries the scars of a system not our own, shaped by the gravity of alien suns, perhaps scarred by collisions on worlds long gone. In studying them, humanity is not merely cataloging debris. It is touching the outskirts of other star systems without ever leaving its own. 3i Atlas, though faint, carried with it this same gravity of meaning. Astronomers debated quickly. Was it cometary? Was it asteroidal? Early images suggested a comet-like halo, the faint suggestion of out. But unlike Borisov, which screamed its identity with a bright, active coma, Atlas was subtle, almost reluctant. Its activity seemed muted, inconsistent. Some nights it looked alive, breathing vapor. Other nights it was still, indistinguishable from an inert rock. This duality stirred curiosity. Was it fragmenting, tumbling, or simply smaller than expected? The first official announcements rippled through scientific channels. Papers were drafted, emails surged, and beyond the professional circles, the story began to filter into the public sphere. Newspapers and websites wrote of a new ʻOumuamua, headlines carrying the thrill of mystery. The public remembered the debates of 2017. Was ʻOumuamua natural or artificial, comet or alien probe? Atlas, too, carried the same aura of uncertainty. But among scientists, the fascination was quieter, more measured. They understood the rarity, the improbability. Billions of icy fragments must be drifting through the galaxy, cast out by the violence of planet formation. Yet for 3 of them to pass within reach of human instruments in such a short span, it was a reminder that the universe is far stranger and far more abundant than statistics often suggest. On that April night, when Atlas was first glimpsed, few could have known the depth of questions it would inspire. But within days, astronomers around the world were united in pursuit, chasing the faint light of a stranger between the stars. Their instruments became like nets cast into a black sea, straining to catch every glimmer, every photon, before the tide carried it away forever. And so the story of 3i Atlas begins not with answers, but with a glimpse, a fragile trace of motion across the sky, a reminder that the solar system is not an island, but a shore, and that beyond it lies an ocean filled with fragments, messengers, and mysteries still waiting to arrive. In the silence of the cosmic ocean, chance is merciless. Stars are separated by gulfs of light years, each one hosting planets, comets, and asteroids born from its own nebular womb. Most of those fragments never leave home. They orbit, collide, or fall into the fire of their parent star. For a fragment to escape at all requires violence, a gravitational slingshot, a planetary upheaval, the raw chaos of formation itself. And for one of those exiles to then wander for millions of years, threading the void between stars, and finally cross paths with our tiny solar system, it astronomers once believed the odds of ever seeing such a thing were vanishingly small. For centuries, no telescope had caught even a whisper of such a traveler. The solar system seemed a sealed stage, its cast of comets and asteroids, all local, all familiar. Then, in 2017, ʻOumuamua appeared. The impossible had become real. 2 years later, Borisov followed, glowing with the unmistakable signature of frozen gases from another sun. In the history of humanity, only 2 had ever been seen, and yet, within a single year, the skies revealed another. 3.1 Atlas, the third interstellar object. To some, it was exhilarating. To others, unsettling. How could the universe deliver 3 in such quick succession, after billions of years of silence? Was the cosmos trying to remind humanity of its openness, its constant exchange of matter across the stars? Or were humans only just now learning to see what had always been passing silently overhead? The shock lies not only in the rarity, but in the mathematics of probability. Astronomers estimate that trillions of icy fragments have been cast adrift from planetary systems across the galaxy. Yet the volume of space is so immense that even oceans of debris should appear sparse when spread across its expanse. For Earth, orbiting a modest yellow star in an average spiral arm, the expectation was that such visitors would be practically invisible. ʻOumuamua changed that calculus. It passed within 0.25 astronomical units of Earth closer than Mars. Borisov came after more comet-like, venting gases, its tail stretching with alien frost. And now Atlas, faint, fragmented, its behavior unstable. 3 objects out of the abyss, each arriving within the brief span of human memory. The probability felt skewed, as though the universe were unveiling a pattern long hidden. The comparisons began immediately. ʻOumuamua was long and thin, or perhaps wide and flat. Its brightness suggested extreme elongation, though its true form was never resolved. It accelerated strangely, defying the expected pull of gravity, sparking theories that stretched from icy hydrogen to alien technology. Borisov, by contrast, seemed familiar. A comet venting cyanide and water, behaving almost exactly as comets in our solar system do. It was alien in origin, but not in form. So where did Atlas belong? In its early observations, it flickered with inconsistency. Some images showed the faint coma of a comet, others did not. Its brightness shifted unpredictably, suggesting a body tumbling through space or fragmenting into smaller shards. It was neither as enigmatic as ʻOumuamua nor as conventional as Borisov. It occupied a strange middle ground, a visitor that carried both the signs of cometary life and the silence of asteroidal death. This uncertainty was itself shocking. Astronomers had hoped that a third interstellar object might provide clarity, a kind of cosmic tiebreaker between the mysteries of ʻOumuamua and the familiarity of Borisov. Instead, Atlas deepened the puzzle. Its behavior refused simple categorization, as though the universe were deliberately resisting definition. Brightness variations became a central focus. As Atlas approached perihelion, its glow fluctuated in ways that could not be easily reconciled with models of cometary activity. Some astronomers proposed that it was breaking apart under the heat of the sun, shedding fragments invisible to telescopes but altering the light curve. Others suggested an irregular shape, tumbling as it rotated, producing alternating flashes of brightness and shadow. Each explanation raised more questions than it answered. The shape itself remained elusive. ʻOumuamua had provoked astonishment by appearing elongated beyond anything previously seen 10 times longer than wide. Perhaps a shard, perhaps a disk. Atlas did not deliver such a dramatic silhouette, yet its irregularities echoed the same defiance of expectation. If interstellar objects were simply random fragments of rock and ice, one might expect them to resemble the comets of our system. Yet each one revealed so far had been strange in its own way, as though shaped by unfamiliar hands. Even the trajectory carried its own enigma. Its hyperbolic path was undeniable, but its eccentricity How far its orbit diverged from a closed ellipse suggested an origin far outside. Tracing its course backward pointed, not to any nearby star, but to the dark, anonymous, interstellar void. Its birthplace remained hidden, its history erased by millions of years of wandering. Atlas was a stranger without a past, carrying only the scars of its exile. For scientists accustomed to the predictability of orbital mechanics, this refusal to conform was a shock. Astronomy is built on patterns, comets that flare when heated, asteroids that remain inert, orbits that reveal their origins. But ATLAs blurred those boundaries. It was both and neither, alive and inert, a paradox drifting across the sky. The emotional weight of this contradiction was profound. Humanity had waited millennia for its first interstellar visitor, then reeled at the shock of ʻOumuamua. It had found comfort in the familiarity of Borisov, proof that some interstellar travelers behaved as expected. Atlas should have fit neatly into one of those categories. Instead, it tore the categories apart. This was the true scientific shock. The realization that interstellar debris may not conform to any simple taxonomy. Each object could be unique, shaped by forces alien to human experience. ʻOumuamua may have been a fragment of an icy exoplanet, Borisov a comet from a cold dwarf star, Atlas perhaps the splinter of a disrupted world. The variety suggested not anomaly, but rule. The universe might not offer uniformity, but endless diversity. Each fragment a signature of chaos in distant systems. And so astronomers found themselves in a deeper tension. On one hand, the probability of seeing 3 interstellar objects so quickly defied expectation. On the other, the uniqueness of each suggested an inexhaustible variety waiting to be found. The cosmos was more crowded and more unpredictable than ever imagined. It was not just a matter of classification. If such visitors were common, then the solar system is not a sealed vault but a porous shore. Earth, by extension, is not isolated but immersed in a galactic tide. Each object that arrives is a reminder of this truth, a shard of distant history passing through human vision for only a moment before vanishing forever. Atlas embodied that paradox, a visitor that should not exist, appearing when probability said it should not, behaving in ways that defied expectation. It was fragile, faint, unstable, and yet undeniable. A cosmic contradiction, a riddle written in ice and stone. For the scientists who traced its arc, who stared at its faint glow through sleepless nights, the shock was more than intellectual. It was existential. If the universe could place 3 such strangers at Earth's doorstep in so short a span, what else might wander unseen through the void? How many emissaries have already passed, invisible in the centuries before telescopes? And how many more are still to come, carrying with them the untold stories of alien worlds? The solar system, once thought an isolated harbor, was revealed as a crossroad. And at that crossroad, ATLAs drifted silently. A visitor that, by all accounts, should not be here yet, was. The moment 3I Atlas was announced as interstellar, the chase began. Across the world, telescopes were hurriedly aimed toward its faint, flickering light. It was not a dazzling comet streaking through the sky, nor a fiery intruder visible to the naked eye. It was fragile barely above the threshold of detection, a ghost sliding across the dark. To glimpse it required patience, long exposures, and careful subtraction of starlight. Observatories became hunting camps. From Hawaii to the Canary Islands, from Chile's Atacama Desert to Arizona's high mesas, astronomers raced against time. Every night mattered. Every night could be the last before Atlas faded into invisibility. The data gathered was precious, each photon carrying a piece of truth from a fragment that had traveled across interstellar space. Through spectroscopy, scientists attempted to read its chemical signature, dissecting its light into a spectrum. The results suggested traces of activity, perhaps water, vapor, or simple gases sublimating from its surface as it neared the sun. A faint coma seemed to shimmer around it, inconsistent and weak, but real. Yet the signal was elusive. Unlike Borisov, which loudly declared itself a comet, its emissions were faint, sometimes absent, sometimes fleeting. Astronomers debated whether it was fragmenting, shedding icy shards invisible to telescopes, or whether it was simply too small to maintain activity. In some frames it looked alive. In others it seemed inert, a paradox of stone and vapor. The attempt to measure dust revealed another puzzle. If Atlas was indeed a comet, it should have ejected enough material to leave a distinct tail. Yet no clear, persistent tail was seen. Perhaps the fragments were too fine, scattering light below detectability. Perhaps its activity was short-lived, bursts of sublimation quickly stifled by its structure. Whatever the cause, Atlas refused to match expectations. To understand its journey, its hyperbolic trajectory was unmistakable, a path that carried it in from the interstellar void, around the sun, and back out again, never to return. By tracing this path backward through simulations, researchers attempted to identify its birthplace. But the galaxy is vast, and the uncertainties in its motion multiplied over millions of years. Backward projections pointed not to a particular star, but to regions of the sky dense with possibility. One model suggested it could have been ejected from the disk of our galaxy near Cygnus. Another placed its origin near the Carina Arm, where clusters of young stars form planetary systems. But none of these reconstructions could be definitive. Somewhere, long ago, a system had cast Atlas out. Which one would remain forever hidden? What the data revealed was frustratingly limited. Its brightness curve suggested it was small, perhaps a few hundred meters across at most. Its fluctuations hinted at an irregular shape or ongoing fragmentation. Its faint coma suggested some level of activity, though weak. But beyond that, telescopes can capture light across billions of light years, but only if the source is luminous. An interstellar rock, a few hundred meters wide, reflects sunlight poorly. Its surface is dark, its glow faint. Even at its closest, Atlas was little more than a whisper against the backdrop of stars. Time, too, was an enemy. Unlike comets that circle the sun in repeating orbits, interstellar objects pass once and vanish. Astronomers had only weeks to gather data before Atlas receded beyond reach, slipping into the abyss from which it came. It was like trying to study a bird in flight with a single photograph, a fragmentary glimpse of something already gone. This brevity lent a kind of desperation to the chase. Scientists spoke of it as a fleeting gift, one that could not be stored or revisited. Every cloudy night, every missed observation felt like an irretrievable loss. The universe had offered a messenger, but only briefly, and it demanded urgency in exchange. And yet, even in fragments, the data carried meaning. Atlas confirmed that interstellar visitors come in forms as diverse as they are rare. It was not a silent shard like ʻOumuamua, nor a blazing comet like Borisov. It was something between a fractured traveler, whispering activity but resisting clarity. Its very ambiguity was its revelation. The galaxy sends not one kind of messenger, but many. In its faintness, Atlas forced astronomers to confront the limitations of human vision. What else had passed unseen in centuries before wide-field surveys existed? How many wanderers had drifted silently through the solar system, visible only as possibilities, lost to the naked eye? Atlas, small and faint as it was likely only the tip of an unseen population, an ocean of fragments threading the galaxy, each carrying the histories of alien systems. For a moment, humanity had caught one, and though its secrets remained half hidden, its presence alone was a revelation. It proved that interstellar wanderers are not rare myths, but real, passing through in numbers greater than ever imagined. The deeper astronomers peered into the sky, the more they discovered not clarity but mystery. Atlas gave them fragments, spectral hints, brightness variations, orbital trajectories that led only into darkness. It was both gift and enigma, and then, as quickly as it appeared, it began to fade. Observatories recorded their final measurements, light curves diminishing into noise. The data was archived, papers drafted, debates begun. But the object itself was gone, continuing its eternal path outward, back into the interstellar deep. What remained was a lingering silence, the silence of an unanswered question. What was 3I Atlas? A comet half alive, a fragment breaking apart, a survivor of worlds we will never know. Its light no longer reaches human eyes, but its riddle endures, echoing in the records of those brief weeks when the cosmos opened a window, and humanity gazed through. The deeper astronomers peered into the faint trace of 3I Atlas, the more confounding its nature became. For every observation that seemed to clarify, another appeared to contradict. What should have been a simple classification, comet or asteroid, active or inert, dissolved into a tangle of inconsistencies. The object was not content to be understood. It seemed to blur itself deliberately, a riddle carved in ice and dust. One of the earliest puzzles was its brightness. Comets and asteroids both reveal themselves through light, the reflection of sunlight across their surfaces, modulated by shape, spin, and activity. Normally, those variations are steady, predictable. But Atlas betrayed something else. Its brightness fluctuated erratically, sometimes brighter than models allowed, sometimes dimmer, sometimes changing with a rhythm that suggested tumbling. Yet the amplitude of those changes was greater than expected, as if the object was irregular in shape or breaking into smaller pieces. The possibility of elongation was raised. ʻOumuamua had shocked the world with its extreme proportions, perhaps a cigar-shaped shard, or a flattened disk tumbling end over end. Could Atlas be another such anomaly? Data hinted at irregular geometry, but it was impossible to pin down. It lacked the stark elongation of ʻOumuamua, yet it was not round, not simple. Each fluctuation hinted at hidden complexity, a body neither stable nor whole. Some images suggested fragmentation, pieces breaking away under solar heat. Others hinted at a rotation so chaotic that sunlight scattered unpredictably across its surface. But confirmation remained beyond reach. Telescopes strained against its faintness. Resolution dissolved before answers could form. ATLAS slipped between categories. Not cigar, not sphere, not cometary nucleus, but something fractured, undecided. The question of activity deepened the tension. On some nights, faint gas seemed to surround it, a thin coma whispering of sublimating ice. On others, it vanished entirely, leaving Atlas indistinguishable from a dark asteroid. Why would a comet flicker between life and death? Borisov, the second interstellar visitor, had shown clearly with cometary activity, its gases detected in multiple bands. ʻOumuamua, by contrast, showed none, yet drifted with unexplained acceleration. Atlas appeared to hover between them, alive one moment, inert the next, as though caught in a fragile state of decay. This inconsistency was perhaps its most haunting feature. Was it a cometary fragment so depleted that it could barely sustain sublimation? Was it breaking apart in spurts, each burst of gas a final gasp? Or had its journey through interstellar space baked its surface into sterility, allowing only occasional vents of activity? Each explanation opened possibilities, but none could be confirmed. The timeline compounded the frustration. Atlas was faint from the moment of discovery, visible only to the largest telescopes, and for only a short interval. Weeks after its announcement, its brightness began to wane as it retreated from the sun, slipping into the background noise of the cosmos. What humanity had was a thin sliver of data, a handful of spectra, a collection of light curves. For an object that had wandered for millions of years, the window of study was brutally short, a cosmic whisper passing through. Impossible to hold. This brevity created a haunting sense of loss. For astronomers, ATLAS was not just a discovery, but a fleeting opportunity, a messenger whose words could barely be caught before it vanished. Every unanswered question felt amplified by the knowledge that it could not be revisited. The universe had offered a clue, but only in fragments, and then withdrawn it into silence. The inconsistency of Atlas raised a deeper possibility, one that unsettled even the most careful minds. What if every interstellar visitor leaves behind more questions than answers? What if their value lies not in what they reveal, but in how they confound? ʻOumuamua had unsettled physics with its acceleration and shape, Borisov reassured, then puzzled again with its chemical oddities. ATLAS followed the pattern. Instead of clarity, it brought ambiguity. Together, they suggested a universe not inclined toward simplicity, but toward diversity, so extreme that each visitor is singular, no archetype exists. No single model will fit them all. Each one is a messenger, yes, but each speaks in its own tongue, half understood, half erased by distance and time. For scientists who long for patterns, this was cosmic frustration. The role of science is to find laws beneath the chaos, to unify anomalies under broader principles. But here, in this new field of interstellar debris, the pattern was contradiction itself. The solar system was a stage suddenly open to actors from distant realms, and every performance defied rehearsal. Emotionally, it carried weight. To gaze upon Atlas was to glimpse a traveler older than human civilization, older than Earth's memory of itself. It had drifted between stars, perhaps for millions of years, before colliding with the narrow window of human technology. And yet, at that moment of encounter, it gave almost nothing of itself: faint signals, inconsistent behavior, unanswered questions. The scientists who watched it fade felt a paradoxical mixture of triumph and despair. Triumph, because they had witnessed one of the rarest events in astronomy, the passage of a confirmed interstellar object. Despair, because the mystery only deepened with every measurement, leaving them to wonder whether human instruments would ever be enough. Like the after-image of a star seen only once, Atlas was a visitor that grew darker the closer it was studied. Not because its light diminished, but because its contradictions multiplied. Each observation cast longer shadows, each theory raised new unknowns. The mystery did not shrink under scrutiny, it expanded, until it filled the void with silence. Perhaps this is the true nature of interstellar objects, to remind humanity of its limits. The galaxy is not a place of easy answers. It is a place of fragments, scattered stories, half-glimpsed messengers, passing too quickly to be fully heard. Atlas was one such messenger, a voice from beyond that left more echoes than words. And so the mystery grew darker, not in the sense of fading, but in the sense of deepening, of becoming richer, denser, more unknowable. For every scientist awake in the night, staring at faint signals on a monitor, it was a reminder that the universe does not yield its truths easily. Sometimes it offers only riddles. Atlas was one of those riddles, a fragment from another star, tumbling, flickering, alive and inert, too faint to be seen clearly, too important to be ignored. It arrived, it confounded, and it departed, leaving behind not clarity, but wonder, not answers, but questions. And perhaps that is its final gift, but an endless mystery, deepening with every glimpse in the silence that followed Atlas's fading light. The work of imagination began. For astronomers, data is the bedrock, but speculation is the bridge. When an object vanishes beyond reach, theories remain as the only scaffolding with which to build meaning. Atlas, like ʻOumuamua before it, demanded such scaffolding. Its strangeness, its inconsistencies, its very presence, invited explanations that ranged from the cautious to the radical, from the strictly mathematical to the philosophically daring. Fragments of Utha, most widely accepted possibility, is also the simplest. That Atlas was a fragment of a young planetary system, ejected during its chaotic birth. When stars form, disks of gas and dust whirl around them, gradually assembling into planets, moons, and asteroids. But this process is violent. Collisions are constant. Models suggest that for every planet that forms, countless smaller fragments are expelled into interstellar space, doomed to wander forever. In this picture, Atlas may have been one such exile. Perhaps it was once a small comet orbiting a distant sun, circling faithfully until a giant planet hurled it away. For millions of years, it drifted, frozen and forgotten, until it stumbled into the sun's light. Its faint coma, its whisper of activity, would then be the last breath of an object born in a nursery far away, carrying the chemistry of an alien world, the violence of collision. Other theory imagines a more dramatic origin, not a gentle ejection, but a catastrophic impact to worlds colliding in the furnace of a distant system. When planets crash, the fragments can be ejected at tremendous speeds, cast into space as shards of stone and ice. Perhaps Atlas was such a shard, the remnant of a planetary surface shattered long ago. Its irregular brightness, its potential fragmentation, its inconsistent activity, all might be the scars of ancient violence. This vision turns Atlas into a kind of tombstone, a relic of a world that no longer exists. Its fractured form would be a message not of life, but of death. A reminder that solar systems are sculpted as much by destruction as by creation. Whispers of red dwarfs. Some astronomers looked to red dwarf stars, the most common stars in the galaxy. These small, cool suns are known for their tempestuous youth, bombarding their planets with flares and gravitational shifts. Around them, dusty disks often linger, producing debris clouds that could shed fragments into interstellar space. If a TLAS came from such a system, its faintness and fragile activity might be explained by its long exposure to harsh stellar winds. Its journey through space would then be measured not just in distance, but in endurance. The thought is humbling that a fragment so small, so fragile, could survive the tantrums of a red dwarf, then endure millions of years in the void, only to pass briefly before our telescopes. ATLAS becomes not only a messenger, but a survivor. The radical question beyond these natural explanations lies a more unsettling possibility, one that arises whenever anomalies resist easy categorization. Could such objects be artificial? Could Atlas, like ʻOumuamua before it, be something other than a simple shard of rock or ice? The idea was most famously raised by Avi Loeb, the Harvard astronomer who suggested that ʻOumuamua might be a fragment of alien engineering, perhaps a light sail or probe drifting through the galaxy. His proposal sparked controversy, embraced by some as bold speculation, dismissed by others as sensational. Most astronomers prefer natural explanations, rooted in collisions, comets, and planetary physics. Yet the absence of clarity leaves a sliver of possibility open. Atlas, with its inconsistent activity and irregular brightness, fueled similar whispers. Could its fragmentation be mechanical rather than natural? Could its faint outgassing be a malfunction, the remnants of something once designed? Such ideas are not supported by evidence, but they persist in the imagination, because the unknown invites them. Scientists themselves tread carefully here. Most reject exotic claims outright, not because they are impossible, but because extraordinary claims require extraordinary evidence. And evidence, in the case of Atlas, was painfully lacking. Still, even rejection cannot erase the philosophical weight of the question. If even one such object were artificial, it would change everything. And until interstellar objects can be studied up close, that door remains cracked open. Solar systems in death and birth, regardless of whether Atlas was comet, shard, or something stranger. Each hypothesis ties back to a larger truth. Interstellar objects are evidence that solar systems are not static, but alive. They form, they break, they eject, they evolve. Each fragment is a chapter torn from the book of another star's history. If Atlas was a cometary fragment, it tells of planet formation and the scattering of icy bodies. If it was a shard of collision, it speaks of worlds destroyed. If it came from a red dwarf's debris cloud, it reveals the turbulence of smaller suns. And if, in the most radical sense, it were artificial, it would testify to intelligence beyond Earth. In every scenario, Atlas becomes more than a rock. It is an artifact of cosmic process, a relic of forces that humans cannot witness directly. To study it is to practice interstellar archaeology, piecing together stories from fragments washed ashore. Interstellar archaeology is perhaps the most poetic role of objects like ATLAs. They are not just debris, but relics. Each one is a fossil of a system unseen, carrying the chemistry, the scars, and the silence of its origin. Like shards of pottery from ancient ruins, they tell stories even in their incompleteness. ʻOumuamua told of elongation and acceleration. Borisov told of icy comets glowing with alien frost. Atlas told of fragility, inconsistency, paradox. Together, they suggest a galaxy full of stories written in stone and ice, drifting endlessly, and humanity stands at the edge of this tide, catching only a handful, trying to read them before they slip away. It is humbling and it is haunting, for in the end, every theory remains tentative. The data is incomplete. The visitors are fleeting. Natural explanations dominate, but speculation persists. The mystery is not resolved, only deepened. Perhaps that is the gift of Atlas and its kin, not to provide final answers, but to expand the imagination, to remind humanity that the universe is filled with fragments of dreams and nightmares, drifting between the stars. Each one a messenger, each one a question, each one a fragment of a story far larger than our own. The discovery of 31 ATLAS revealed not only the mystery of the object itself, but the limits of human vision. A faint smudge in the sky, present for only weeks, slipping quickly into darkness, it forced astronomy to confront its own fragility. To study the rarest visitors in the cosmos requires speed, precision, and above all, collaboration. Atlas was a messenger that underscored this truth. The eyes of science must be sharper, faster, and more united than ever before. The global chase from the moment Atlas was confirmed interstellar. Telescopes across the world turned to follow. Observatories in Hawaii, Chile, Spain, South Africa, and beyond entered into a silent relay. As the Earth rotated, each site picked up the chase where the previous one left off. The object was faint, often at the edge of detection, requiring long exposures and careful processing. But together, the network of human eyes across the planet created a mosaic of data. This coordination is one of the quiet triumphs of modern astronomy. It reflects a recognition that no single observatory can hold the sky alone. Interstellar visitors demand a choreography across continents, a global collaboration where data flows without borders. When an object like Atlas arrives, humanity responds as a single organism, its telescopes blinking in rhythm as the night moves from east to west. Even this united pursuit struggled against the challenge of faintness. Atlas was small, dark, and fast. It moved across the starfield with deceptive subtlety, its trajectory shifting each night, its brightness fading as it retreated. Observers had to calculate positions with precision, predict its arc, and aim their instruments at just the right point in the sky. To miss by a fraction was to lose it entirely. The challenge of the faint and the fast interstellar objects carry with them a paradox. They are both enormous and tiny, vast in their significance, yet minuscule in their observable presence. They are large enough to survive interstellar journeys of millions of years, yet small enough to vanish from human view in weeks. Their speed compounds the difficulty. To move fast enough to escape the sun's gravity is to pass too quickly for deep study. ʻOumuamua, Borisov, Atlas each underscored this dilemma. They appear suddenly, stay briefly, and vanish forever. Astronomers are left scrambling, their tools straining at the edges of sensitivity. The faintness tests the limits of CCD detectors, while the speed compresses observation windows. This tension has driven the next generation of astronomical tools, designed not only to see deeper into the sky, but to react faster to the unexpected. The promise of the Rubin Observatory. At the forefront of this new vision stands the Vera C. Rubin Observatory in Chile, preparing to begin its legacy survey of space and time (LSST). With a field of view so wide it can image the entire southern sky every few nights, the Rubin Observatory is poised to transform the search for interstellar visitors. Its 3.2 gigapixel camera, the largest ever built for astronomy, will detect faint moving objects with unprecedented efficiency. Where Pan-STARRS and Atlas could discover the occasional intruder, Rubin is expected to find many. Estimates suggest it could detect one or more interstellar objects every year, turning rare miracles into regular encounters. For the first time, humanity may build a statistical population of these wanderers, measuring not just isolated examples, but trends. What is their true abundance? What sizes dominate? Do they lean cometary or asteroidal, or something stranger? Each detection will refine the picture of how solar systems across the galaxy shed their fragments. Rubin will not end the mystery, but it will flood it with new data. Atlas was faint, fleeting, almost lost. Rubin's watchful. I will ensure that fewer such messengers slip by unnoticed. The depth of James Webb. While Rubin will sweep the sky for new arrivals, the James Webb Space Telescope (JWST) offers another kind of vision, depth. Orbiting far beyond Earth's atmosphere, Webb peers in infrared, sensitive to the faint heat of cold objects. For interstellar wanderers, often small and dark, this is a crucial advantage. Infrared light reveals what visible light conceals: the warmth of ice sublimating, the faint glow of dust, the composition of surfaces. With Webb, astronomers hope to decode the chemical fingerprints of these visitors, measuring the ices and minerals that bind them. Such data could confirm their origins, linking them to known processes in planet formation, or distinguishing them as truly alien in composition. Had Webb been fully operational during the passage of ATLAS, the insights might have been transformative. Its instruments could have captured details too faint for ground-based telescopes, perhaps settling the debate over its activity. In the future, when Rubin detects new interstellar objects, Webb may become the tool that dissects them, one sweeping the sky, the other probing deeply. Together, they represent a dual vision, breadth and depth, discovery and analysis, survey and detail. Humanity's eyes grow sharper, preparing for the next visitor. Dreams of interception, yet some dream of going further still. Telescopes capture light, but what if humanity could intercept an interstellar object directly, sending a probe to meet it in flight? The idea once fantasy, is gaining momentum. Projects inspired by breakthrough starshot. Imagine small, lightweight spacecraft, accelerated to extraordinary speeds, capable of rendezvous with fast-moving objects. Concepts like the ESA's Comet Interceptor, already approved, hint at this possibility. A spacecraft designed to wait in space, ready to launch toward a newly discovered visitor. The challenge is speed. Interstellar objects move tens of kilometers per second, their paths known only shortly before closest approach. To intercept requires not only fast spacecraft, but rapid mobilization missions, launched in months, not decades. For now, this lies on the edge of feasibility. But, in principle, humanity could one day chase and catch such a messenger, studying it up close, drilling into its mysteries, transforming speculation into evidence. The dream is intoxicating, to hold in human instruments a piece of another star's history, to sample material that has traveled across light years. Atlas, faint and fleeting, science advances through modeling. Orbital simulations attempt to estimate the population of interstellar objects, their frequency, their origins. By tracing backward the trajectories of ʻOumuamua, Borisov, and Atlas, astronomers seek statistical clues. How often should such objects pass through? What masses dominate? What stars are most likely to produce them? These models suggest that the galaxy is teeming with fragments, trillions upon trillions, wandering unseen. Most will never pass close enough to be detected, but the density is greater than once believed. The rapid succession of 3 detections hints not at anomaly, but at abundance. The solar system, it seems, is not isolated, but immersed in a galactic tide. The models also explore their fates. Most will pass through untouched, but a few may collide with planets, seeding surfaces with alien material. Some may linger in the Oort cloud, captured weakly by the sun's gravity. Earth itself may already hold fragments of interstellar rock, unnoticed among its stones. Such thoughts blur the boundaries between local and cosmic, reminding humanity that every world is porous, open to exchange. Lessons of ATLOs from all this. One lesson stands clear. Humanity must be ready. Atlas arrived, faint, fragile, fleeting, and nearly escaped full detection. It exposed the gaps in readiness, the need for wider surveys, faster coordination, deeper instruments. Each interstellar visitor is both gift and test, and Atlas showed that the test is not yet passed, but readiness is growing. Rubin will scan the sky, Webb will probe with infrared. Global networks will coordinate in hours, and missions may one day launch to intercept. The next Atlas will not pass so quietly. Humanity is building the capacity to hear these messengers more clearly, to read their stories more fully, to turn fleeting glimpses into lasting understanding. The eyes that awaits at the night sky turns, and telescopes wait. There is a sense of anticipation. Somewhere out there, countless fragments drift, born of alien systems, carrying within them the chemistry of other suns, the scars of other worlds. At any moment, one of them could be on its way, invisible still. Rubin will see it. Webb will study it. Perhaps even spacecraft will chase it. Humanity waits at the shoreline of the cosmic ocean, nets cast wide, ready for the next tide. Atlas, though faint, left this legacy. It reminded the world that the universe sends visitors without warning, and that preparation is everything. The eyes of science must always be open, because in the silence between stars, the next messenger is already on its way. In the vast silence of the galaxy, a fragment drifts. It carries no name, no purpose, no map of its journey. It is the detritus of processes far larger than itself: planetary births, stellar deaths, collisions, and expulsions. Yet, when such a fragment crosses into the solar system, it transforms. For a brief moment, it becomes a mirror, reflecting not only sunlight, but the questions of an entire species staring upward. This is the paradox of interstellar visitors. They are both profoundly alien and deeply intimate. They do not belong here, yet they brush against humanity's sky, writing fleeting marks into its instruments. They are not sent with intention, yet they arrive as if delivering messages. They do not speak, but their silence resounds with meaning. Messengers across the dark ʻOumuamua was the first to shake this silence. A shard elongated beyond reason, accelerating in ways that defied known physics. It was both object and omen, a reminder that human knowledge is still porous, unable to contain all possibilities. It left as suddenly as it arrived, trailing not certainty but questions. Borisov followed, a cometary specter glowing with alien frost. It was familiar, and yet not. Its chemistry suggested kinship with the comets of our own solar system. It reassured that some processes are universal, while also reminding that every system writes its own variations. Then came Atlas, faint, fractured, inconsistent. It whispered activity, then withdrew. It glimmered with hints of cometary life, then fell silent. Neither wholly comet nor wholly asteroid, it became a paradox, drifting in twilight, where ʻOumuamua, astonished, and Borisov, confirmed, Atlas, unsettled. Its legacy was not clarity, but ambiguity. Together, they form a trinity of messengers, three voices from beyond, each speaking differently, each impossible to ignore. They are fragments, but also stories. They are debris, but also witnesses. They are accidents of celestial mechanics. The tension of they carry the weight. What is most haunting is the asymmetry of encounter. Humanity cannot go to them. The stars remain beyond reach, their distances swallowing centuries of propulsion. But they can come to us, by chance, by gravity, by the long tides of interstellar drift. Fragments from alien systems cross our orbit. We stand on the shore, unable to sail outward, but watching as flotsam washes in from seas we cannot yet navigate. This creates a poetic tension. Each fragment is both answer and riddle. It is proof that the galaxy is connected, that systems shed their children, and that those children wander. Yet it also reminds us of how little we can do with that knowledge. We see them for a moment, we gather a sliver of data, and then they are gone. They do not linger for study. They do not repeat their visits. Each one is a once-in-history encounter. It is as though the cosmos sends postcards from distant lands, but never returns an address. Connected by fragment sand, yet these visitors whisper of connection. For billions of years, interstellar fragments have wandered unseen. Some pass through unnoticed. Some may have collided with Earth, sprinkling it with alien dust, seeding it with atoms forged around other suns. The boundaries between star systems are not impermeable. They are porous. The galaxy is not a collection of isolated islands, but an ocean with currents that mingle and mix. to recognize this is to feel a shift in perspective. Humanity has long imagined itself confined to one solar system, separated by impossible gulfs. But ʻOumuamua, Borisov, and ATLAS remind us that the universe itself is not so strict. Material flows between stars. Fragments cross the void. The galaxy is, in truth, a web of exchange. What does it mean if every world carries pieces of others? What if the stone beneath our feet contains atoms once belonging to alien comets, shattered long before Earth existed? In that sense, interstellar visitors are not outsiders at all, but distant relatives returning, briefly, to remind us of our place in a shared cosmos. The hidden multitudes, the haunting implication is that what we have seen is only a fraction. If 3 have been detected in as many years, how many have passed unseen through the deep past before telescopes swept the skies? How many drift even now, invisible in the darkness, too small or too faint to notice? Models suggest trillions. Countless fragments wandering between stars, debris from billions of planetary systems, invisible rivers of rock and ice threading the galaxy, silent caravans of orphaned worlds. The 3 we know are not anomalies, but heralds of a vast hidden population. To know this is to feel awe and unease, because it reveals the galaxy as alive with motion, exchange, and encounter. Unease, because it suggests that every fragment we see is a reminder of all those we cannot. The visible is only the edge of the unseen. The philosophy of strangers in this, there lies a deeper reflection. Humanity has always been shaped by strangers, the unknown tribe, the distant land, the visitor from beyond the horizon. Each encounter reshaped identity, expanded maps, rewrote histories. Now, on the cosmic stage, the same pattern repeats. Interstellar objects are strangers in the most profound sense. They come from beyond, not just borders, but stars. What meaning do they carry? Some see them as evidence of universality. The processes that shape planets and comets are not unique, but everywhere. Others see them as omens of possibility, that among these fragments may lie the seeds of life, or even the traces of intelligence. Still others see them simply as reminders of humility, that the universe is not closed, but open, and that humanity is far from the center of its story. In all cases, they force reflection. They compel a recognition that Earth is not isolated, that the night sky is not a distant painting, but a living sea whose currents sometimes wash against our world. The ghost of ATLAS, and so we return to faint, fleeting, already gone. A messenger glimpsed only briefly, leaving more questions than answers. It was small, fragile, inconsistent, yet in its very fragility lay its power. It reminded us that the most delicate of visitors can still alter our understanding of the cosmos. ATLAS will never return. It is gone, moving outward, its path carrying it back into the anonymity of interstellar space. No telescope will find it again. No spacecraft will intercept it. What remains is its trace, its data, its mission, the memory of a time when the galaxy brushed against us once more. This is the paradox of cosmic strangers. They do not stay. They cannot be known fully, yet they reshape us simply by passing through. Closing reflection. ʻOumuamua, Borisov, Atlas. 3 voices, 3 messages, 3 questions. Together they reveal a universe, not of isolation, but of connection. A universe where stars share their fragments, where systems exchange material, where the void is alive with wanderers. Humanity stands at the shoreline, unable yet to sail outward, but watching as the tide brings pieces of distant worlds. Each one is both answer and riddle, proof and question. They remind us that the cosmos is not silent, but speaks in fragments, if only we are listening. And perhaps this is the meaning of Atlas, faint though it was, that even the briefest glimpse can transform understanding, that even the smallest fragment can carry the weight of the infinite. The galaxy is alive with strangers, and each one, no matter how faint, no matter how fleeting, reshapes forever the way we see the sea of stars.